And we can also start by answering your questions. Otherwise, I have questions for you. You have questions going on? Yes. Yes, I will. Can you call it out to me? Is this the web work from sections 5.3 and 5.4? Got it? You don't have it? Am I just making it up? What? Do you know the number? Put the formulas up there again. See them all. I'm trying about the day before class meets is to put kind of an outline of the notes for the next class meeting on Blackboard. So if you ever think about it, go look at it there. So I've got kind of a handout that I'm going to go through. You got it? We'll put our answer like that. And can you tell me the angle again, please? 3, 4, 5. We're going to use a sum or difference formula. Whoops. To find the exact value of the sine of 345 degrees. And the tricky part is to get your answer in this form. So I'm going to make a couple of attempts at doing this. First, I'm going to go through our angles that we know and love and see if I can find any that add to 345 degrees. So let's see. We've got 0 degrees, 30 degrees, 60. Oops, I need to put 45 in here. 45 degrees, 60 degrees, and 90 degrees. And so then if I move out into quadrant 2, let's see. I've got 120 degrees. 90 plus 90 is 180 degrees. Let's see, 45 plus 90 is 135 degrees. 180 minus 30 is 150 degrees. That's quadrant 2. In quadrant 3, let's see, this would be, this actually 180 should have gone here. And let's make this 270. Okay, so now in quadrant 3, let's see, 180 plus 30 is 210. 180 plus 45 is 225. 180 plus 60 is 240. And then in quadrant 4, let's see, 360 minus 30 is 330. 360 minus 45 is 315. 360 minus 60 is 300. And then my 2 pi is 360 degrees. So I'm looking in that list of numbers there to see if I can find any that will add to 345 or subtract to 345. And my first attempt is going to be these two. I'm going to get 345 degrees by adding a 300-degree angle with a 45-degree angle. And then I'm going to try to put my answer in this form. If I can, then I found it. If not, then I've got to go the difference formula. So my first attempt, we're going to try the sine of 345 degrees as the sine of 300 degrees plus 45 degrees. So now I'm going to use the sine of A plus B formula. That's right here. So let me copy that formula right here so I can move that page out of the way. That the sine of A plus B is equal to the sine of the first angle, cosine of the second angle, plus the cosine of the first angle, sine of the second angle. A in our example is 300 degrees and B is 45 degrees. So here we go. We have the sine of the first angle, so sine of 300 degrees. Cosine of the second angle gives me cosine of 45 degrees. Plus, let me scroll down here, cosine of the first angle will be cosine of 300 degrees times the sine of 45 degrees. With the note that our 300-degree angle is in quadrant 4. 300 degrees corresponded to a reference angle of 60 degrees. The ordered pair at a 60-degree angle. The ordered pair at a 60-degree angle was x is 1/2, y is square root of 3/2. X being the cosine of the angle and y is the sine of the angle. At 45 degrees, both sine and cosine are square root of 2/2. So let's fill this in. In quadrant 4, the sine is a negative number. It'll be a negative square root of 3/2. Cosine of 45 is the square root of 2/2. In quadrant 4, cosine's a positive number. It's a positive 1/2. And then the sine of 45 degrees is square root of 2/2. Now I want to manipulate that answer so that it has the right form as specified in WebWork. So I can see where I get the 4. Both of these have a 2 times 2 in the denominator. So there's the 4. Then I have minus square root of 3 times the square root of 2 plus the square root of 2. And so it looks like if I change the order in which I've written these, right, addition is commutative, and then factor out the common factor of square root of 2, I think I have it in the right form. So I'm going to change the order. When I pull out a square root of 2 here, I get a 1. And then this provides the minus sign. Pull out a square root of 2 here, I get square root of 3. And I've got it in the right form, where A is 2 and B is 3. We got the right thing. Okay? Yes, sir.
Can you explain that last step one more time?
I first changed the order of arithmetic. I put the square root of 2 in front and then the other one behind. Right? I can add them this way or that way, but I got to keep the sign associated with it. And then I factored out a square root of 2. Well, if I pull out a square root of 2 here, I have to have a multiplier to put it back in if I were to distribute the square root of 2 through. So yes, sir.
Given that
Sign of which letter? U, mu, U. Sign of U is
cosine of u is
okay.
once we use the tangent tangent of u plus pi over 2.
Given that, find the tangent of U plus pi over 2. Do you know what number this one is? Okay. Okay, so sine is given as a positive number. You're told cosine is positive. That's enough to decide what quadrant angle U is in. Can you tell me a quadrant in which both sine and cosine are positive simultaneously? That says angle U is in quadrant 1. If I draw this quadrant 1 angle and put angle U here, the sine represents the opposite over the hypotenuse. And then we have to find this adjacent side so that I'll be able to find the tangent. So let's first complete that triangle using the Pythagorean theorem. It says that a squared plus 11 squared is 61 squared. 11 squared is 121. Oh, what is 61 squared? Let's see. 61 times 61. All right, so 6 times 1 is 6. 6 times 6 is 36. Maybe it's 3,721. That looks like a good enough number. So now when I subtract 121, I get a squared is equal to 3,600, and that's a perfect square. The number I square to get 3,600 would be 60. Now I'm going to find my identity for the tangent of U plus pi over 2. I'm going to use the tangent of A plus B formula. The second from the bottom, the tangent of A plus B is the tangent of A plus the tangent of B divided by 1 minus the product of the tangent of A with the tangent of B. We're going to use U as A, and pi over 2 will be our B. So it's the tangent of the first angle plus the tangent of the second angle divided by 1 minus the tangent of the first angle times the tangent of the second angle. Does anybody know the tangent of pi over 2? It's the sine of pi over 2 divided by the cosine of pi over 2. What's the cosine of pi over 2? Cosine of pi over 2 is 0. So what do we know about the tangent of pi over 2? It's undefined. These two numbers here are undefined, so that makes the tangent of U plus pi over 2 undefined. So the tangent of U plus pi over 2 does not exist. I don't know how you answer that. Does it tell you?
See, that was my problem. I thought that it was undefined, but I didn't know that.
Well, then maybe we need to take a look. Let's see if I can call up a web work here.
just type it out.
It doesn't tell you in the instructions what to do if it's undefined.
I just want to get that was last week, but I don't know if we all get the same problem. I had like the same issue. With the
All right,
4.5
let's see if we can get that fixed. All right, where's my dang web work? Right there. This is 5.3, and you said it was number 7. Okay, so this one has a pi. So this one would work. Let's see. How do I find one that doesn't work? Ugh! I don't know. I don't know what to tell you. What have you tried typing in?
Undefined, I could try to
UND, maybe infinity. Try typing in infinity. DNE. I think they've used either undefined or infinity. Try that. And I don't know because mine shows a working one.
I send you an email with the correct.
Yep, I can do that. That'd be probably the easiest thing to do. Good. Okay, so I'll look that up, what to do about that. Does not exist, or undefined, or infinity. Is my bet. Yes, sir.
This is on 5.1-5.2. And this is some kind of expression, which is sine to the 4th power x minus cosine to the 4th power x.
Simplify that, okay. So I feel like we may have done this one. We do that one in here? So what I'm finding about the questions that you guys are asking is factoring. Factoring seems to be a little bit of a gap for you. And I don't know how to fix that gap. We're going to look at this as the difference of squares. Right, that is the sine squared of x squared minus the cosine squared of x squared. And we're going to use the difference of square formulas, that a squared minus b squared factors as the product of a minus b times a plus b. How many of you have seen this before in a previous life? What are you doing having previous lives? Are you Hindu or something? Or do we all get previous lives and we just don't know about it? Were you a cat? I feel like I was a cat in a previous life based upon how I can just sleep anywhere. Oh. Okay, so this is the difference of squares where a is going to be sine squared and b is going to be cosine squared. So I should be able to factor this as sine squared minus cosine squared times sine squared plus cosine squared. Okay, then we can write this in terms of a single trig function after we recognize that expression in the second parentheses. What is sine squared plus cosine squared? That's 1. Now we have ways of writing that in terms of either sine only or cosine only. I can't remember which one it takes, so I'll write it both ways and you can decide which way you like it. We know that sine squared plus cosine squared is 1. So if I choose to replace cosine squared, I would put in 1 minus sine squared. So right here, I'm going to put in 1 minus sine squared. But this minus sign is there, so make sure you use parentheses. As those parentheses are holding that minus sign, I'm going to take the parentheses off and distribute the minus sign. So I'll have sine squared of x minus 1 plus sine squared of x. And these two guys are like terms, so I can add them by adding the coefficients. So sine squared plus sine squared gives us 2 sine squared. So I have 2 sine squared of x, and then I still have the minus 1 from the previous step. I think that will be accepted by this web work. Don't know. Okay. What else? See if any of you guys have anything. Can you do number 9 on 5354? All right, let me see if I can find a number 9 on 5354. Oh, come on. Number 9 on 5354. That's problem 7. Okay, so here's number 9, at least my version of it on 5354. Let me write that down. I've got the tangent of 74 degrees minus the tangent of 14 degrees divided by 1 plus the product of tangent of 74 degrees times the tangent of 14 degrees. And it says write this as the tangent of a degrees. And then once we do that, figure out what value that is. So the trick is to recognize that expression as being one of our identities. So let me pull my identities up here again. That looks like the one at the very bottom, because I have 2 tangents in the numerator and they're subtracted. The product of 2 tangents in the denominator with the plus sign. So I'm going to use that formula. I will use the formula that the tangent of A minus B can be written as the tangent of A minus the tangent of B over 1 plus the product. Looks just like that, where A from this formula, this A right here is 74 degrees, and the B in this formula is 14 degrees, not the A and the B from the web work. So what that says is that this should be able to be combined as a single tangent of A minus B. And if I do the subtraction, 14 degrees from 74 degrees is 60 degrees. So this A right here is 60 degrees. Now let's figure out the tangent of 60 degrees. The ordered pair at 60 degrees is 1/2 square root of 3 over 2, and tangent is y over x. So this is going to be the square root of 3 over 2 divided by 1/2. which is the square root of 3 over 2 times 2 over 1. That's the square root of 3. So the b value that we're looking for is 3. Okay? Yes,
How can we subtract 74 and 14?
because we put them together according to the formula. In the parentheses, the subtraction comes first. So this expression in its spread out form can be put together as a single tangent by subtracting the two angles. So not only do we need to be able to use the formulas from this form and spread it out to that form, but recognize it from its spread out form to its condensed form. Okay. Any others? Yes.
Number 6 on 5354, it says, given cosine A equals negative root 39 over 8. And pi is less than A, which is less than 3 pi over 2. And sine of B equals negative 2 over 5. And B is in quadrant 4. Use sum and difference formulas to find the following: tangent of A plus B. And don't use decimals.
All righty. What number did you say this one was? Number 6 on 5.3, 5.4. Okay, so remember that the given angles, if you know the sine or cosine or any one trig function of a single angle, you know them all. And not only that, this tells you what quadrant they're in. We're going to need to know all sides of those triangles because the tangent of A plus B is going to look like, let me write down the identity here. The tangent of A plus B is going to look like the tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B. So I know the cosine of A, I should be able to draw that triangle and figure out the tangent of A. I know the sine of A, I can do the same thing to get the tangent of B. This tells me that A is in a particular quadrant. Which quadrant contains angles of measure between pi and 3 pi over 2? That's quadrant 3. So I'm going to use this information here, and I'm going to draw an angle in quadrant 3 and find all 3 sides of the right triangle produced by that angle. So here my coordinate plane. There's my quadrant 3 angle. Label it as angle A. Cosine consists of the adjacent side over the hypotenuse. The hypotenuse will be the positive 8. Since x is going back negative, the adjacent side is negative square root of 39. I've got to find that y value down there. And so let's just do the Pythagorean theorem, call this number y for now. And we have that y squared plus 8 squared is, I said that backwards. Okay, so I didn't use a pencil. This should be, well, let's just try it again. Y squared plus negative square root of 39 squared is 8 squared. Solving that for y. When I square the negative, I get a positive. When I square the square root, I get the number in the square root sign. So I have y squared plus 39 is 64. I'm going to subtract 64 from both sides. I'm sorry, 39 from both sides. And I have y squared is equal to, looks like 25. Y is going down in quadrant 3, so I'm going to take Y to be -5. Now I'm going to do the same thing with this information. I guess I'm going to come way down here to do it. I'm going to draw a quadrant 4 triangle. There's my quadrant 4 triangle with angle B. The sign is Y over R. The Y is the negative number because we're going down. R is always positive. And now I need the X coordinate there. So let's write the Pythagorean theorem, which is with the variable X. X squared plus -2 squared is 5 squared. So I have X squared plus 4 is 25. Solve for X squared. To get X squared is 21. X is positive in quadrant 4, and here it's a positive square root of 21. So I want everybody to look up here at angle A and tell me the tangent of angle A. There you go. And the negatives will cancel. The negative over a negative. So let's write the tangent of A is 5 over the square root of 39. That's going to go right here. Now we're looking down here and you're going to tell me the tangent of angle B. What is the tangent of angle B? -2 over the square root of 21. And so let's fill those in down there. I have 1 minus 5 over the square root of 39 times -2 over the square root of 21. And I think you can enter your answer like that. Okay. Are we good? Okay, well, let's do one of my examples. There's our formulas. Let's see. I think we've worked some like that. So let me skip number 1 and let's look at number 2. Come back into focus here. On number 2, it says find the exact value of the cosine of 20 degrees times the sine of 70 degrees plus the cosine of 70 degrees times the sine of 20 degrees. And the hint is we don't know those values without a calculator, but that looks an awfully lot like one of our sum and difference formulas. Put them down here. There's our sum and difference formulas. Which one does it look the most like? Which one has cosine sine plus cosine sine? That looks just like the third one, sine of A plus B. So I'm going to use the sine of A plus B is sine A cosine B plus cosine A sine B. So in our example, the B is the 70, one of them 70, one of them's 20. It doesn't matter which one. And we're going to take it from the right-hand side and express it in a condensed form as the left-hand side. So this should be able to be written as the sine of 70 degrees plus 20 degrees. And when you add those, you do get a known angle. You get the sine of 90 degrees. Does anybody know the sine of 90 degrees? It is 1. So that expression is 1. All right, we may have done number 3 before, but what the heck, it's written down there. Let's do number 3. Find the exact value of 7 pi over 12 using the hint that the angles pi over 3 plus pi over 4 add to 7 pi over 12. Because if I get a common denominator, pi over 3 is 4 pi over 12, and pi over 4 is 3 pi over 12. So that says in order to find the tangent of 7 pi over 12, just write that as the sum of 2 known angles. Write that as the tangent of 4 pi over 12 plus 3 pi over 12. And from the hint, those simplify to pi over 3 plus pi over 4. Now we're going to use the tangent of a plus b formula. There's the tangent of a plus b. It's got the sum of the 2 angles in the numerator, the product of the 2 angles in the denominator behind a minus sign subtracted from 1. So I'm going to write that out where a is pi thirds and b is pi fourths. So I get the tangent of pi thirds plus the tangent of pi fourths divided by 1 minus tangent of pi thirds times the tangent of pi fourths. Pi thirds is the same as 60 degrees. The ordered pair at 60 degrees is 1/2 square root of 3 over 2. And tangent is the y over the x. So we divided square root of 3 over 2 by 1/2 a minute ago and got square root of 3. So I'm going to just write that as the square root of 3. What is the tangent of pi over 4? 1. And then downstairs I get 1 minus the square root of 3 times 1. So there's our answer. 1 plus the square root of 3 over 1 minus the square root of 3. Okay. So that's how we use the sum and difference formulas. Now I'm going to use the sum and difference formulas to generate new formulas for you in sections 5.5. Yep, in 5.5, and then in 5.6 we'll get half angle formulas. So let me start a new page. So that was page 1. There's page 2. And here come page 3. Section 5.5, we're going to do double angle formulas. And so I'm going to start with the formula that we have from before. The cosine of a plus b looked like cosine, cosine. So cosine a, cosine b, but the cosine formula had a minus in between. Sine a, sine b. I'm going to use that, change every b to an a. so that I have the cosine of a plus a, where a plus a is 2a. So I'm going to generate a formula for the cosine of 2 times a, using the fact that 2 times a is a plus a. So go back in here, and where you see these two b's, put in a couple of a's. You should get cosine of a times the cosine of a minus the sine of a times the sine of a. When you multiply two cosines together of the same angle, you'll get a cosine squared of that angle. Same deal here, this will give us a sine squared. So the cosine of 2a will look like cosine squared of a minus sine squared of a. Let's hang on to that. But do the same thing now to get a double angle formula for the sine of 2 times a. I'm going to use the fact that the sine of a plus b goes sine a cosine b plus cosine a sine b. My goal is to get a formula for the sine of 2 times a. So all I got to do is, again, think of 2 times a as a plus a. So go in that formula right above it, replace b with a, and then it'll look like sine a cosine a plus cosine a sine a. So even though those are written in opposite orders, they're the same term. Sine times cosine is the same as cosine times sine. So I've got a pair of them added together, which means they add to 2 of those. The sine of 2 times an angle is 2 times the sine of the single angle cosine of the single angle. So that's the identity for the sine of 2 times a. Finally, to generate the sum formula for the tangent, I can just take the sine over the cosine, or I can use the tangent of a plus b. The tangent of a plus b has a numerator that looks like the tangent of a plus the tangent of b, and a denominator that looks like 1 minus the tangent of a times the tangent of b. Using that, the tangent of 2 times a is just the tangent of a plus a. So replace each b with an a. Then I have the tangent of a plus the tangent of a over 1 minus the tangent of a times the tangent of a. And that's going to simplify as 2 of the tangents of a by adding. And then when I multiply, I get a tangent squared. So in the denominator, I have 1 minus the tangent squared of a. So 3 more formulas. Now I'm going to show you why we need them. Remember that I can't just add. If I want the sine of a plus b, I can't just say it's the sine of a plus the sine of b. In a similar manner, the cosine of twice an angle is not cosine of twice the cosine of the single angle. So I'm going to show you that I need them first. There's all the angles written in nice pretty form. So if you want this pretty, all you gotta do is download this handout from Blackboard later on. But I want to verify now that the cosine of twice an angle is not twice the cosine of the angle. And the easy ones to use maybe are 30 degrees and 60 degrees. 60 degrees is twice 30 degrees, right? I'm going to take theta is 30 degrees, so that 2 theta is 60 degrees. And so if I want to compute the cosine of 2 theta using these examples, then that's just the cosine of 60 degrees. Cosine of 60 degrees is square root of 3 over 2. If I want to compute 2 times the cosine of the single angle, 2 times the cosine of the single angle is 2 times the cosine of 30 degrees. 30 degrees is the same as pi over 6. I just got those backwards, didn't I? 60 degrees is pi over 3. Cosine of pi over 3 is a half. So I screwed this one up. That's a half. 30 degrees is pi over 6. Cosine of pi over 6 is the square root of 3 over 2. So 2 times the square root of 3 over 2 simplifies to the square root of 3. And so notice that the cosine of 2 theta is not equal to 2 times the cosine of theta. Same thing will work for the sine. Sine of 60 degrees is not twice the sine of 30 degrees. You get the same pair of numbers, but in a different order. So fight that temptation. If there's something inside the parentheses with the angle, you can't factor it out from trig functions. You can't distribute. You can't do all the things that you want to do with it. That's stuck in there, protected by the angle. Now let's mimic all the problems that we've done earlier. If you know the sine or cosine of a single angle, then you know all 6 of them. And if you know those, then you should know the sum of angles and the double angles. So on my second example, I said, you're given that the cosine of an angle S is 3/5, and angle S is in quadrant 4. Find the cosine of 2S, sine of 2S, and the tangent of 2S. So we first write these double angles in terms of the single angles using our brand new, never been used identities. So let me refresh your memory. The cosine of 2 times any angle is the cosine of the first angle squared minus the sine of the angle squared. Right? So the cosine of 2S will be the cosine squared of S minus the sine squared of S. I've got the value of the cosine of S. We're going to use it to find the sine of S. So I'm going to draw an angle in a triangle in quadrant 4 and get the other side. There's angle S. Cosine is adjacent over hypotenuse. And so this side is going to be 4, but it's in quadrant 4. Y values in quadrant 4 are negative. So the sine of that angle is opposite over hypotenuse, or -4/5. So we'll put the cosine of that angle here. Then we have to square it. Put the sine of that angle here and square it. And then we'll combine those two. 3/5 squared is 9 over 25. 4/5 squared is 16 over 25. So I have 9/25 minus 16/25, which is a -7/25. Easy enough? Just like before, we just have some more angles to fill in. All right, the next one, the sine of twice the angle, has as its identity 2 times the sine of the angle times the cosine of the angle, of the single angle. 2 sine of S cosine of S is the identity for the sine of a double angle. And then we have the cosine of S is 3/5. The picture tells us the sine of S is -4/5. plug those values in for the trig functions. And we're done. Multiply across the top. 3 times 4 is 12, times 2 is 24. It's a negative 24 over 25. The next one asks for the tangent of 2s. I have an identity for it, but I'm just going to use the definition that the tangent is the sine over the cosine. And I just found those two guys. So instead of using that identity, I'll use our definition that the tangent of 2s is the sine of 2s divided by the cosine of 2s. We have those numbers above. The sine of 2 times s is negative 24 over 25. The cosine of 2s is negative 7 over 25. So if we do the flip and multiply step, first notice that I have a negative over a negative, and I'm going to go ahead and cancel that and make that positive. So we'll take 24 over 25 and multiply it by the reciprocal 25 over 7. The 25s cancel, and so our tangent is 24 over 7. Now look at those three values. The cosine of 2s is negative, the sine of 2s is negative, and the tangent of 2s is positive. In what quadrant is angle 2s? Quadrant 3. Tangents positive, sine and cosine are negative. So in what quadrant? No, 4 times 7 is 28.
Oh,
But nice
I
try.
had a 3 and then that was right. Okay, so
Right, tangent is negative, sine and cosine are, a tangent is positive, sine and cosine are negative, so 2s has to be in quadrant 3. There are actually 3 forms of the identity for the double angle for the cosine. And in the next example, we're going to generate all 3 forms. We already have one of them, so we're going to generate the other 2. So in my next example, use the Pythagorean identity to find 2 more alternate forms for the cosine of twice an angle. So here's the form that we generated a minute ago. We have that the cosine of twice an angle is equal to the cosine squared of the angle minus the sine squared of the angle. That's the double angle formula that I got when I went to the sum formula and replaced B with A. Now it says, go to your Pythagorean identity. Your Pythagorean identity relates sine squareds and cosine squareds. Sine squared plus cosine squared is 1. So let me abbreviate the Pythagorean identity. Sine squared plus cosine squared is 1. So another version of that identity is that sine squared is 1 minus cosine squared. I'm going to take that and put that in right here, and that'll simplify to another version of the cosine of 2 times A. So let's take this out, put that in there. Then we have cosine of 2A is cosine squared of A minus, and now in here I'm going to put 1 minus the cosine squared of A. Let's take off those parentheses and distribute the minus sign. So it'll look like cosine squared of A minus 1 plus the cosine squared of A. And those two guys are like terms added together to give us 2 cosine squared of A. Here's the second version of that double angle formula. 2 cosine squared of A minus 1. My other choice was to go to my Pythagorean identity and solve for cosine squared. Cosine squared is 1 minus sine squared. So now I'm going to go back over here and I'm going to replace the cosine squared. So another way is start with cosine of 2A is cosine squared of A minus sine squared of A. But this time, let's replace cosine squared with 1 minus sine squared. And we'll get 1 minus sine squared of A minus the given sine squared of A. And that's going to simplify to 1 minus 2 sine squared of A. Three versions of the identity for cosine of 2A. Cosine of 2A is cosine squared minus sine squared. Cosine of A is 2 cosine squared minus 1. Cosine of 2A is 1 minus 2 sine squared of A. You need to be aware that there are three versions of them because we might have to take something from this form and put it back into the form on the left-hand side. They should all give you the same value for the cosine of 2A. All right, I'm gonna scoot this up. I'm going to give you the value of the cosine of 2A and ask you to find the other 6 trig functions of the single angle. Actually, I used a theta. So find cosine, sine, tangent, secant, cosecant, and cotangent, our 6 favorite trig functions. If we know the cosine of the double angle is -12/13 and the single angle is in which quadrant? Quadrant 3. So I need to go from information about the double angle to give me information about the single angle. So I'm going to start with, well, let's see, I know cosine of 2A, but I don't know these two. So I'm going to maybe start with the middle one. I know this number. I'll put that number in here and I'll solve for this number here. And then once I know the cosine of A, I've got them all. So that's my plan. I'm going to start with the cosine of twice the angle. I better use a theta to match up here. Twice the angle is 2 times the cosine squared of the single angle minus 1. The -12/13 is the value of the guy here on the left. So I'm going to take that out and put -12/13 in there. And I'm going to solve this equation first for the cosine squared, and then I'll take square roots to get the cosine of the single angle. See how that's going to work? All right, so let's get the cosine squared by itself. I'm going to need to add 1 to both sides. So I'm going to add 1 here. And I'm going to add 1 here. So here I'll have 2 cosine squared of theta. In order to add 1, I need a common denominator. So think of this 1 as 13 over 13. So I have negative 12 over 13 plus 13 over 13. 1 over 13, positive 1 over 13. Right? Because this one is 13 over 13. Now I'm going to divide by 2. Dividing by 2 is the same as multiplying by a half. So I get cosine squared of theta on the right-hand side, 1 over 26 on the left-hand side. So the cosine of theta is going to be the square root of that number. But remember, in quadrant 3, cosine is negative. So we take the negative square root of it. Since the square root of 1 is just 1, I can write the cosine of theta as negative 1 over root 26. Now we have one of the trig values of theta. Let's get them all by drawing a quick right triangle. I'll draw the triangle over here and I'll put the other trig functions over there. Draw this angle, draw this triangle in quadrant 3. Angle theta is in quadrant 3. Cosine describes adjacent over the hypotenuse. The adjacent in quadrant 3 is going to be the negative 1. The hypotenuse is the square root of 26. We need the y value there. Satisfying y squared plus negative 1 squared is the square root of 26 squared. So y squared plus 1 is 26. That says that y squared is 25. Y is going to be the square root of 25, but y is also negative in quadrant 3. So y is negative 5. Okay, so let's work our way down the line. We've got cosine of theta. Use that picture and tell me what the sine of angle theta is. There you go. Now we're on tangent of theta. Keep going, you're on a roll. All right. Then let's start flipping these over. Flip over the cosine to get the secant. Flip over the sine to get the cosecant. And flip over the tangent to get the cotangent. Okay? Once you get one, the rest is pretty quick. Yes, sir.
When you made the square root of 126 negative, you did that in the square root of 31, right?
Correct. When I go to take square roots, then I use the information in quadrant 3 that both x and y are negative. Both sine and cosine are negative, so I take the negative square root. You can do everything with positive numbers, just adjust the sign in the end and make sure that you get everything right. Or you look like you want some more. Come up here and look at your faces. Come here. Is that part of the semester where you're all burnt out? Well, it could be worse. You could be going to work at McDonald's every single day. But no, you're training yourselves to be professionals. Sitting in an office every day, drawing plans, looking at, that's better than going to McDonald's every day of your life. So feel blessed that you're here and act dadgum interested. And I would like fries with that. Okay, next example. We get to do some practice with the expression that we had a minute ago. We started with an example that looks like simplify cosine to the fourth minus sine to the fourth of an angle. And we simplified it, and I want you to recognize now that what it simplified to was one of our double angle formulas. So let's do all those steps again, but this time we get to use that cute little alpha as our angle. So we're going to start with the left-hand side. Cosine to the fourth of alpha minus sine to the fourth of alpha. And the way we simplified that again was to consider the difference of squares. That this was the cosine squared squared, cosine squared of alpha squared minus the sine squared of alpha squared. Again, the difference of squares, a squared minus b squared is what I'm calling the difference of squares. Always, always factors as the product of these two linear factors, a minus b times a plus b. And so ours will factor as cosine squared of alpha minus sine squared of alpha times cosine squared of alpha plus sine squared of alpha. Cosine squared alpha minus sine squared of alpha, cosine squared of alpha plus sine squared of alpha. What was next? Recognizing cosine squared plus sine squared of the same angle is always 1. So now I just have cosine squared of alpha minus sine squared of alpha. And so we're going to pull down our Pythagorean identity. We're not our Pythagorean identity, our double angle identity from earlier on. And that's that guy. Cosine of 2a is cosine squared minus sine squared. So then we're done. Keep my pages organized here. I got 1, 2, 3, 4. That must be page number 5. Looky there, there's some more on the back. That'll be page number 6. Back in. Still waiting on you? In section 5.3, we did things like find the exact value of the sine of 15 degrees by thinking of 15 degrees as 45 degrees minus 30 degrees. But now I can find, well, not yet. Soon, I'm going to give you some half angle formulas. In the next example, I want you to find the product of the sine of 15 degrees times the cosine of 15 degrees. So can I turn it now? Without a calculator, find the exact value of the product of the sine of 15 times the cosine of 15. So I could go back and generate the sine of 15 by saying it's the sine of 45 minus 30. I can generate the value for the cosine of 15 doing the same thing. But now I have a handy dandy identity that has the product of the sine and the cosine together. Let me see where I got it. Look at this identity right here. The sine of twice an angle has 2 times the sine of the angle, the cosine of the angle here. I'm just missing the 2. So that's my hint. Hint. The sine of twice any angle is 2 times the sine of an angle times the cosine of the angle. So if I put the sine of 15 degrees here and the cosine of 15 degrees here, with this 2 in front of it, that should be equal to the sine of 2 times 15 degrees. And 2 times 15 is 30. Does anybody know the sine of 30 degrees? 30 degrees is the same as pi over 6. Sine of pi over 6 is a half. Now I'm going to take this equation and solve it for the sine of 15 degrees times the cosine of 15 degrees by dividing both sides by 2. But remember, dividing by 2 is the same as multiplying by a half. So let's multiply this side by a half and multiply that side by a half. And so 1/4 is the exact value of sine of 15 degrees times the cosine of 15 degrees. Okay? The next example says simplify cosine squared of 9x minus sine squared of 9x. So on any other day, I would have said, well, I'm going to simplify that by factoring that as the difference of squares. Except today. Today, I saw an expression that looked like a cosine squared minus a sine squared. So let me dig out my identities from today again and see if you can spot it. Got any identity from today that looks like a cosine squared minus a sine squared? Maybe the very first one. Cosine of 2a is cosine squared of a minus sine squared of a. So that's what I'm going to say here. I'm going to recognize that cosine of twice an angle looks like the cosine squared of the single angle minus the sine squared of the single angle. So I've got the right-hand side of this. I've got the cosine squared of 9x minus the sine squared of 9x. So that says I should be able to write that as the cosine of 2 times 9x. And then I'm done. 2 times 9x is 18x. So I have simplified it right there. Cosine squared a minus sine squared of a is cosine of 2a. Cosine squared of 9x minus sine squared of 9x is cosine of 18x, 2 times 9x. Okay? The next bit is to generate half angle formulas. A half angle formula tells me what the cosine of, say, a over 2 is, if I know the cosine of a, and what the sine of a over 2 is, if I know the sine of a. So we've got one more section, one more bit of identities that I don't think we can do a whole section in 2 minutes. Dang the luck. I'd say we could stay longer, but I think there's a class in here after this. So thus endeth another day. On Thursday, we're going to do the half angle formulas. All right, I'm ending it for y'all. You're welcome to go back to bed.